The VLAN trunking protocol is said by some to be, quote, the best thing since sliced bread, end quote. Others claim that VTP, or the VLAN trunking protocol, is, quote, invented by terrorists to destroy networks around the world, end quote. So, where are these two bipolar positions coming from on VTP? That's what we're going to talk about here. We'll look at VTP, the good, the bad, and the ugly. Then we'll get in depth into what VTP is all about, the modes, what VLAN pruning is, how that comes into play, VTP configuration. We're going to set up VTP between our switches, and then we'll wrap up this whole VLAN subseries by talking about common VLAN issues. Here's the scoop. The goal of the VLAN trunking protocol is very simple. It's to ease your daily administrative burdens of creating VLANs. Now, the first thing I've got to say about VTP is it was misnamed. I can't stand the name VLAN trunking protocol because it's not a trunking protocol. What are the two trunking protocols that we have? ISL, 802.1q. That's it, period. And ISL is going away, so there really is only one trunking protocol we use today. VLAN trunking protocol is not a trunking protocol, but what it is a VLAN replication protocol. That's what it should have been called, VRP. Maybe that was taken. The way it works is all of your switches, when you pull them out of the box and get them connected up, start with this very simple system of VTP revision numbers. And that is the double-edged sword of VTP. Its simplicity is what can kill it. And let me give you a demonstration. When you pull your switches out of the box, they only have one VLAN, and that is VLAN 1. Everybody's at VTP Rev 0. So you log into this switch up here. Oh, let me get my pen going. You log into this switch up here and type in, I want to create VLAN 10. So you type in VLAN 10, enter. All of a sudden, your switch goes, okay, VLAN change, clink, VTP Rev 1. Let me send a VTP update. Goes down to this one. It says, oh, VTP Rev 1, Rev 1, Rev 1. They all flip on over to VTP Rev 1, and suddenly VLAN 10 magically appears on all of these switches. We had VLAN 20 up here. I type in VLAN 20, VTP Rev 2, Rev 2, Rev 2. It goes down to all of these different switches, and they get the revision 2 and add VLAN 20 to their database. Now, that's the end result of what we see. We actually see that taking place on our switches, but what we don't see is the technical details of how that happens behind the scenes. The switches replicate their VLAN database to each other, and anytime somebody has a later revision number, they're like, oh, great, new database, totally better than mine. I will flush my database, everything that I know about, and replace it with yours. So whoosh, those two VLANs show up. This database gets flushed and replaced with this one. So if I delete VLAN 10, deleted, VTP Rev 3, Rev 3, Rev 3, everybody flushes their databases and replaces it with the latest and greatest one. So that's the basics of how VTP works. Now let me show you that, and by the way, let me stop right there and emphasize the good before I get to the bad. The good side of VTP is, think of your organization, or if you have a very small company, think of a big one. How many switches do you think exist in, say, an enterprise organization, a campus network? Maybe 20 on the very low end, maybe 50? Maybe 100 different switches in all these different locations around the campus, and that's just getting started. Now, if I were to have to add a VLAN to all 100 switches, without VTP, what that means is I'm going to every single switch. Sure, it's via Telnet, but who wants to Telnet to 100 switches and adding VLAN 100 or whatever it is to every single switch in my organization? It can be painful. So VTP eases that load for me by just creating it once, and it replicates it everywhere. That's the good side. The bad side is this. Let's say you finish watching the BCMSN series here, and you're thinking, this is awesome. I want to get, I'm getting into this. I'm going to build my own home lab. So you go on eBay and you're searching around and you're thinking, you know what? I can see a switch here. It says Cisco 2900 XL switch, buy it now price for $20. And you're like, wow. And you look at the description and it says, reputable seller, used for years in .com companies, their loss, your gain, and the eBay lingo. And you're like, oh great, buy it now. And you make your PayPal payment and it doesn't take long. And all of a sudden, shoo, this little switch shows up in the mail. And I'm telling you, it's an exciting time. You unbox the Switch and you get into the Switch and one of my favorite things to do when I get stuff off of eBay is to do password recovery, because most of the time the people that sell stuff on eBay, they don't even know what it is. They just like, hey, this looks cool, let's sell it on eBay. So you log into the Switch, it's got a password that immediately should tell you there's a config on this from a company. So you do a password recovery on the Switch and you start looking at their old config. I've done this a few times, and I'm telling you, if you haven't done it, it's great. So you're scanning the config, and you actually see how the company's set up, and you're all excited. So anyway, you've got this switch at home, and you're practicing on some labs, and maybe it's VTP Rev 1302. That's just it's been in .com company for years. That's what it's at, and before long, you're sitting there at home, and you're like, I gotta go to work. You're like, well, I don't really do much at work anyway, and maybe I could take some of the downtime at the office to study and go after my Cisco certification, and I'm gonna bring the Switch to work. So you bring it to work, and you're playing with it and creating VLANs and messing with spanning tree and learning all kinds of stuff. This story is going somewhere, by the way. And all of a sudden, you have this brilliant idea. You think, you know what? I can make a real network here in my cubicle. I can, take my Switch, plug in a couple laptops here into my Switch or my desktop and my laptop or whatever the case is, and I can just grab a crossover cable and plug it right there into the port in my wall and have a real working network. So you do. You plug in that crossover cable and you're like, this is going to be great. And all of a sudden you see Bob down the hall kind of stick his head up above the cubicle, and Bob's like, hey, Jim, you able to get on the internet? And Jim's like, no, I can't. Email isn't even working. And and as a side note, little sidebar here, isn't it funny how in just about every business around the world, if the internet goes down, immediately everybody knows and everybody panics. But like major servers, accounting databases, they can all go away, and at least take them a little time to know. So the moral of the story there, in the Cisco network, you can hose up anything productive, but just don't down the internet access, and at least you got some time before people start whining. So anyway, back to the story. Bob and Jim are above I don't know, nothing's going on. Meanwhile, you're kind of, unplugging your crossover cable and shoving everything in a file cabinet. Here's what happened. When you connected that crossover cable to the port in the wall, this switch, if it was able to negotiate a trunk with the other side, sent a VTP update and says, hey, everybody, I've got VTP Rev 1302. And maybe on this switch, you've got VLAN 100 and 200 that you've created. And this switch is sitting there, and it goes, that's great. We're on VTP 3, it's like, give me your database. So it takes that Rev 1302, flushes its old database along with all its old VLANs. They all go away, all gone, and replace them with VLANs 100 and 200. It takes less than a second. It's very fast. And wham, all the switches in the network lose their existing VLANs 10 and 20 and replace them with 100 and 200. Now the problem is all of the ports in your company, or this little scenario here, were assigned to VLAN 10 and VLAN 20. And if a port is assigned to a VLAN and that VLAN just disappears, the port is like, well, where am I? I'm lost. I can't talk to anybody. It literally cannot talk to anything. The ports just disappear from the switch. If you do a show VLAN to see where the ports are assigned, you won't see anything. They're all just gone. All communication goes down. So less than a second, the entire network collapses. Now, the administrator over here, is in a panic at this point. Cell phones ringing and nightmares going on. And the administrator's like, oh, what's going on? And, it takes a while to figure out because nobody thinks all the VLANs disappear. Oh, by the way, as soon as that happened, all of the ports on all the switches turn amber. That's That's your clue right there that this has happened. If a port isn't assigned to a VLAN and it just disappears, it goes amber. So if you're looking at a rack of switches and all of a sudden everything goes orange, panic, because that just happened. All the VLANs disappeared. So the administrator figures out, it's like, oh no, So he pulls the switch off and restores the config from backup and plugs the switch back in. But as soon as he does, what happens? Replication down. We are VTP Rev 1302. You are VTP Rev 2 or 3. And, wham, complete database flush again. The only way the administrator can fix the VLAN database is to manually recreate it on one of those switches and add all the VLANs back in. Now, I've been referring, just because I wouldn't want to draw up a huge penned out scenario. I've been talking about 2 VLANs here. A company may have 10, 20, 30 different VLANs that they have that's spread across the organization. So the administrator has to manually enter those back in and recreate them. By this point in time, in terms of downtime, you're typically talking about 30 minutes to maybe an hour of complete network outage. Now, you can see the double-edged sword of VTP. Now, this scenario, if you know a little bit about VTP, is not as easy to stumble into as maybe I've shown it right here. For instance, the eBay switch isn't going to typically have the same VTP domain name as your organization. We'll see this in just a moment. All the switches, in order for them to talk, have to be assigned to the same VTP domain. Where this sort of scenario usually happens is a lab environment. A company has a lab environment that they have set up, for testing and stuff like that. And the goal of a lab is to mirror the corporate network as close as possible to run some tests before you release things in production. And what would typically cause this is, a simple problem in the network. Hey, we just got 10 more employees. You got another switch? And you look at the inventory, you're like, we're out of switch. And somebody's like, oh, there's one in the lab. Go grab the one in the lab. And you're like, oh yeah, the one in the lab. And this scenario happens right here because the lab switch had the existing previous configuration on there. So VTP can be your best friend if used wisely. Let's look at the details. The first thing to understand about VTP is the 3 different modes that it supports: server, client, and transparent. If you set up VTP servers, which are the default, they have the power to change any of the VLAN information and replicate those changes to all the other switches in your domain. That's where the VTP rev number comes in handy, because that helps all the switches discover who has the latest copy of the VLAN database, since it is a multi-server environment. The theory goes something like this. You should only have one server in your network, and all the rest of the switches should be, whoa, that's a non-Cisco switch, obviously. The rest of them should all be client mode switches. You can see that the clients cannot change VLAN information. They are locked. If you log into a client and type in, I want to create VLAN 20, that means that, well, I should say, it's going to just reject you and say, sorry, this is in VTP client mode. You cannot make changes from here. Likewise, the VTP clients do not save the VLAN configuration. The servers save that config in a file in Flash called vlan.dat. Clients keep it in RAM. So every time they reboot, they have no VLAN database file, and they have to rely on the replication from the server to get the latest copy of the database. Now, the reason I said the theory goes something like this is because, unfortunately, most of the time it remains a theory. As in, everybody starts off having a great config like this, where you've got the one server and many clients in your network. But the problem is that IT people are lazy. I'll be the first to throw myself under the bus with that group. You tell them that into a switch, right? Somebody just said, hey, I need a new VLAN. And you go into the switch and you just type in VLAN 100. And it says, oh, sorry, the switch is client mode. You can't make that change here. What do? You changed over the client to the server mode because you're lazy and you don't remember where the server is in the network, and eventually go back to a multi-master server model anyway. So the client mode is supposed to be good as long as it's backed up by specific company policies saying you don't make changes from clients and you don't change clients back into servers. The VTP transparent mode, you see at the bottom there, is if you don't want to use VTP. That's one of those ones you've been burned, you don't want to use VTP ever again, change all your switches to transparent mode. They become essentially rebel switches at that point, to where if they receive updates from VTP, they will say, I am not going to listen to this. Now they'll pass it through. You can see that second bullet there. It says it passes through the VTP updates in VTP version 2, which all Cisco switches support. So if you had a situation like, let's say this is a transparent mode switch, and then you had another client down here. It could pass the updates through to the client, but it won't listen to the updates themselves. You can create and delete VLANs, and it saves those configurations in the VLAN database file in Flash, but those VLANs are never sent to anybody else. So every switch becomes its own independent authority once you move over to transparent mode. VTP also has a bonus feature called VTP pruning. What this feature does is allow the switches to do some of the work for you in trimming down where broadcast traffic goes. In this example, you can see that we have 3 switches connected through that middle magic port, which is able to handle 2 switch connections per port. And the top 2 switches are the only ones that have devices in the green VLAN. The bottom switch does not. Now, just with the definition of a trunk, the trunk passes all VLAN traffic, so if somebody sends a broadcast on the green VLAN, the bottom switch gets it even though it doesn't have any clients in the green VLAN. VTP pruning uses the VTP technology to allow the switches to notify each other if they do not have any ports in a specific VLAN. Now, we saw early on in, I believe, the previous nugget, yes, and when we talked about trunking, one of the things I mentioned was that you can manually go in there and type in, these are the allowed VLANs on the ports, whereas VTP pruning is an automatic way to do that for you. Now, you know my thoughts on things being auto, but at the same time, I have never run into a problem with VTP pruning other than the fact that it has to be run on VTP capable devices, meaning if you go VTP transparent mode, you obviously can't use that. Likewise, here's another thought for you. VTP pruning only works on VTP servers. So your client switches, if you have clients daisy chained from other clients, they will not be able to do VTP pruning, which is another, I guess you could say, incentive to keep all your switches VTP servers, which is a bad practice in the first place. So follow my logic on that. That's how VTP pruning works. I will say most people don't use it. So VTP pruning is something that is off by default. You just go in and turn it on, and it does its magic. Last thing I want to mention on VTP pruning. This feature prunes the broadcast traffic from reaching the other switches. It does not prune out the actual VLANs. For example, I have the green, red, and blue VLANs here. The green VLAN will still be available on the bottom switch down there. It's not like it just magically disappears from the switch and only appears when you add ports. You'll see it down there because the replication feature is still working. Pruning just eliminates the broadcast traffic from reaching that switch since there are no assigned ports. Now let's get into the configuration of VTP. I'm going to show you a catch that happens on Cisco switches that might throw you off with some new switches you get into your organization. Step 1 in configuration is verifying the current VTP status on every switch. I can't emphasize how important it is to do this, even if you think the switch has no configuration, because if you forget to verify the VTP status, it may just be that eBay switch that wipes out your network. So let me bring up the console connection. Oh, before I do, you can see the live topology I have going at the bottom there. Switch A connected to B and C. So we are on switch A right now, and the key command to verify VTP is not a show run, because most VLAN information is not going to show up in the show run. It's all stored in Flash in this file called vlan.dat, which is not there yet because I haven't configured this. So I'm going to type in show VTP status. That's your #1 command for verifying VTP. So right up front, you can see VTP version is currently 2. However, version 2 mode is disabled. It runs version 1 until you turn on VTP version 2. That's just the maximum the switch can support. This is the key line you're looking for. configuration revision is 0. That means this switch has not received any VTP updates and has no VLANs, or currently is not running a VLAN database that can replicate to other people. As you make changes, that's the revision number that keeps going up. Below that, you see the operating mode right there, which is the server mode. That's the default mode every switch is in. And then you see the domain name. I want to focus on this. The domain name by default is blank. Cisco considers that null. It's at this point that the switch will be in its most susceptible state. Meaning, if I plug it into a network that is running VTP and a trunk port is negotiated with me, VTP runs on top of the trunks, it will take whatever VTP domain name and password the organization has. So what this means is if I plug this switch in, I don't even need the VTP domain name or the password. I'm going to get all of the VTP updates sent down to me. Tell me that's not crazy, because here's my fear. You forget to hard code a cubicle port as an access port, right? You leave it on the dynamic desirable mode. Well, when somebody plugs that in, their switch will negotiate a trunk port with your switch, and if their VTP domain name is set to null or blank, as you can see on the screen right now, that means whatever VTP advertisement they receive, it will automatically configure itself to. Huh. So can you imagine all that security you thought you had by assigning a VTP domain name and password that nobody knew? It's gone because it's sent in clear text over the trunk link. Moral of the story, it is so important that you hard code every port going to a cubicle as an access port. Do not let it negotiate trunks, because if it does, you're doomed in a way. So what I'm going to do is I just want to show you how this works. I'm going to telnet on over to switch B, do a show VTP status over there. You can see server, everything is blanked out as well. I'll go to switch C and do a show VTP status. Blank. Everything is blank. So our organization currently has nothing. So step one is going to be configuring the VTP domain name. Go into global config mode and just type VTP domain and follow that up with the name of the domain. We'll call it CBT Nugget. Enter. You can see right away it says changing from null or blank to CBT Nugget. I exit back out, do a show VTP status. And sure enough, CBT Nugget it is. Now I'm going to hop on over to switch B, show VTP status over there. Look at that. See what I mean? Immediately, poof, since it was null, it became the first name that came to it. I'm going to jump on over to switch C. Just do that show VTP stat and hit the up arrow. And sure enough, it is CBT Nugget as well. So when it is null, it is susceptible. It will become whatever the first name is that you advertise. So with that in place, well, I guess we don't have too much excitement going on because I have not created any VLANs on here. And that is why on my server, when I do a show VTP status, my config rev is currently 0. So if I go into global config mode and type in VLAN 10, we'll say name sales, VLAN 20, name accounting, VLAN 30, name Isabella. That's the name of my first little daughter. And I'll exit out and do a show VTP stat. And you can see the config rev has moved up to 3. Do a show VLAN. And there's my 3 VLANs. Theoretically, well, it should be working. If I jump on over to switch B and do a show VLAN, poof, the same VLANs pop up. Do a show VTP status. You can see the config rev is 3. I know I'm just zooming through this. Hopefully the video is keeping up. If not, it's the beauty of video. Rewind. So the VLANs are replicating over to switch B and switch C. You can see the config rev as 3, show VLAN, and there's my VLANs that are showing up. So VTP is working, it is operational. Now, a few other things. I'm trying to think. That's it. That's all I have to show. Oh, wait, no. Thank you. I put a list over here for myself. Configure the domain name and the password. The password is configured just by going into global config mode and typing VTP password. You can see right there, and voila. By the way, also while we're here, that's how you turn on VTP pruning. VTP version or VTP mode will set. Oops. What mode it runs in. You can see the transparent server and client. VTP version is version 1 or 2. The difference between version 1 and 2, that would be a good thing to know. VTP version 2 adds support for token ring. Woohoo! Just in time, right? But it also gives transparent switches the capability to forward VTP information through them. If you're running VTP version 1, which all switches are running by default, even though it says VTP version 2, you can see version 2 mode is disabled. If you're running version 1, the transparent mode switches will stop VTP broadcasts. They absorb them rather than pass them on. So, let's see. Where am I? VTP domain password. Okay, VTP mode. We've seen configuring the servers, or all of them are servers by default. So let me hop back over here. I'm going to set these guys up as VTP mode client. You can see when I do a show VTP status, it is now in client mode. And what that means is this can no longer create or delete VLANs from the domain. I'll just type in VLAN 40 to create a new one, and it will tell me VLAN not allowed while the device is in client mode. This is what I was mentioning. This is where your self-discipline comes in, because you want to make sure you don't just change it back over to a server and make the change, because that kind of defeats the purposes of clients. VTP version number, I already showed you that. So, just trying to think if there's anything else. VTP just, it's all about the concepts. Like most things in Cisco, not too much to the configuration. Last thing I'll do is hop on over to the VTP, switch C, change that over to VTP mode client. Now let me show you some gotchas. I'm going to type in on switch A, show flash. And you can see, I showed you this right before we got started, there was no VLAN.dat file. Now there is a VLAN.dat. All of your VTP stuff and VLAN stuff, I'll do a show run, include VLAN. You can see that there is nothing in the running config about VLANs. All of that stuff is stored in that VLAN database file. One of the tips that I'll give you, now this is not certification world, this is just real world stuff I've run into. One of the tips that I will give you is if you're working on a used switch, meaning one that's maybe been in production for a while, and you reconfigure it to be in a new VTP domain name or joining a new domain of switches or something to that effect. I have had it happen where I have the domain name, the password, everything exactly correct. And by the way, I should mention as I'm talking, this domain name is case sensitive. So lowercase, uppercase does matter. I've had everything correct, and mode is correct, trunk links are operational, and it does not replicate. I have found that sometimes the VLAN database file cannot handle changes from one domain to another. Like if you do a write erase, and this is a good rule of thumb. I think of all these things as I go here. If you do a write erase to erase the switch, it does not erase the VLAN.dat file. So it will maintain its VLANs, and it will maintain all its VTP stuff. I've found a lot of times if you do a write erase and forget to delete the VLAN database file, the next time you try and set it up for VTP, it gets corrupted. And my point in saying all of this is that if you're having trouble with VTP, and you know everything is right, you know you've got everything set up correctly, try this. Delete the VLAN database file. Do a delete flash :VLAN.dat. It'll ask you to confirm. Run through a couple times, enter, and confirm it. You will have to reboot the switch to clear everything out because it's still in RAM. But a lot of times I find if you have a used switch and you're moving it between VTP domains, that VLAN database file can't handle it, and it kind of gets corrupted in the sense that it won't work anymore for the new VTP domain. You just got to delete it and start over. Now that I think about it, I just jumped a little ahead of myself. I was going to save that for this common VLAN problems slide. One of the problems that you might have, and that's down at the very bottom, is that VLAN database file gets corrupt. So just type in that delete flash colon backslash VLAN.dat and reboot the switch, and that will solve a lot of the VTP problems. I have had that happen, I would say, a dozen times or so, and I've gotten used to just deleting the VLAN database file on older switches. So let me hit the rest of the common VLAN problems that you run into as we wrap up this VLAN subsection here. First off, number one problem I've seen is a native VLAN mismatch. You keep getting all these messages across your console. Native VLAN mismatch. We already talked about the native VLAN, but a mismatch happens when it's assigned differently on both sides of the connections. You want to hard code it so it is the same. Otherwise, you end up with VLAN information bleeding amongst each other. Meaning if one side is VLAN 1 and the other side is VLAN 10, you've essentially linked those two VLANs through the native VLAN mismatch. That's why it's not a message to ignore. I've been into many networks where I log in, I'm like, oh, you got a native VLAN mismatch. They're like, oh yeah, I've seen that message forever, and I don't know how to fix it. And I go, oh, you want to fix that because you've essentially bridged VLAN 1 and VLAN 10 when you do that, since a broadcast for VLAN 10 ends up going across into VLAN 1. So make sure those are matched. Second, trunk auto negotiation issues. My message, don't use the auto negotiation. The number one problem is auto to auto does not become a trunk, and that is by design. The auto mode does not send out DTP messages that try to negotiate a trunk with the other side. So both of them are just sitting there idle saying, okay, is somebody going to do something? But nobody does anything. So if possible, avoid the DTP and set all of your trunks to non-negotiate. That is the best way to hard code everything. The last thing is what we just talked about, VTP updates not applying. Number one steps is to go through and make sure everything matches. Check your domain, check your password, check your version on all your switches. Are they all running version 1 or 2, or you can't have a mix? Verify your trunk links. A lot of people overlook that. VTP is called the VLAN trunking protocol. It's not a trunking protocol. I already mentioned that, but it does only work over trunk links. So make sure that you have trunk links between your switches. And then the last one I already talked about, to delete that file and reboot as a last resort. A lot of stuff on VTP. The good, the bad, and the ugly. What do you think? I'm curious. I'm really curious. I wish I could take a poll. How many of you will use VTP or are using VTP in your organization? And after seeing the ugly, if you will, of VTP, how many of you still want to use it? I will say I still use it. Just to give you a personal experience, I have had it wipe out a network, but I'm telling you, for me, the advantages outweigh the disadvantages. But that's not an opinion for everybody. VTP modes, we talked about server client transparent, transparent being disabling VTP. Pruning being the feature you can turn on from global config mode, just one command line, VTP pruning, enable. And that will turn on pruning for the switches. They have to be the server mode VTP switches to enable the pruning. We walked through the VLAN configuration step by step, and finally looked at troubleshooting common VLAN issues as we wrap up this VLAN subsection of the BCMSN series. I hope this has been informative for you, and I'd like to thank you for viewing.